From the dawn of humanity we have gazed upward at the night sky in wonder. The twinkling stars have beckoned us with their mystery. We are drawn to explore the unknown. Space represents the ultimate frontier. It is a realm of endless possibilities. For centuries, space travel was the stuff of dreams. But in the 20th century, fantasy began to transform into reality. We broke free from Earth's gravity and ventured into the cosmos. The first steps into orbit led to daring missions to the moon. Each achievement fueled our desire to reach further. Today we stand on the cusp of a new era in space exploration. We are determined to stay. The dream of a permanent human presence beyond Earth is within our grasp. This is a pivotal moment in human history. The journey ahead will be fraught with difficulty, but the rewards are immeasurable. By embracing the challenge of space exploration, we stand to unlock profound scientific discoveries. The cosmos awaits and humanity is ready to answer its call. The 21st century has witnessed a resurgence in space exploration. Governments and private companies alike are investing heavily in space programs, driven by a spirit of discovery and a desire to tap into the vast resources of the cosmos. This renewed interest in space is perhaps best exemplified by NASA's Artemis program. A worthy successor to the Apollo missions, Artemis aims to establish a sustainable presence on the moon by the end of this decade. The Artemis program represents a significant leap forward in our capabilities. It will see the first woman and the next man walk on the lunar surface, this time with the goal of staying. A lunar base camp is planned, serving as a hub for scientific research and a testing ground for technologies needed for future missions to Mars and beyond. The program has already achieved significant milestones. The Orion spacecraft, designed to carry astronauts to lunar orbit and beyond, successfully completed its maiden voyage in 2022. Meanwhile, private companies like SpaceX are making their own mark on space exploration. SpaceX, helmed by the visionary Elon Musk, has revolutionized the launch industry with its reusable Falcon rockets. These rockets have drastically reduced the cost of sending payloads into space, making space more accessible than ever before. Beyond launching satellites and cargo, SpaceX has its sights set on Mars. The company is developing the Starship, a fully reusable spacecraft designed to transport humans to Mars and eventually establish a self-sustaining colony on the Red Planet. The emergence of private companies like SpaceX, Blue Origin, and Virgin Galactic has ushered in a new era of commercial spaceflight. These companies are breaking down the barriers to space, making it possible for ordinary citizens to experience the wonders of space travel. Space tourism is no longer a futuristic fantasy, it is rapidly becoming a reality. Virgin Galactic offers suborbital flights that provide a few minutes of weightlessness and breathtaking views of Earth from the edge of space. Blue Origin, founded by Amazon's Jeff Bezos, is developing a reusable suborbital spacecraft called New Shepard, designed for space tourism and scientific research. The company also plans to build a massive, rotating space station called Orbital Reef, which could serve as a platform for microgravity research, space manufacturing, and even space-based hotels. The involvement of private companies in space exploration is not limited to tourism. Companies like Astrobotic and Intuitive Machines are developing robotic landers and rovers to deliver payloads to the moon's surface, opening up new opportunities for lunar science and resource exploration. This commercialization of space is driving innovation and reducing costs, making space more accessible to governments, researchers, and entrepreneurs alike. It is fostering a vibrant and competitive space industry, paving the way for a future where humanity's presence in space is commonplace. While the allure of space exploration is undeniable, the journey is fraught with challenges. The harsh realities of the space environment pose significant dangers to human health and the integrity of spacecraft. One of the most pressing concerns is radiation exposure. Unlike Earth, which is protected by a magnetic field and a thick atmosphere, space is awash in harmful radiation from the sun and other cosmic sources. Prolonged exposure to this radiation can damage DNA, increasing the risk of cancer and other health problems. Another challenge is the unforgiving nature of the vacuum of space. Without the protective cocoon of Earth's atmosphere, even a small breach in a spacecraft's hull can be catastrophic. Micrometeoroids, tiny particles of space debris traveling at high speeds, pose a constant threat, capable of puncturing hulls and damaging equipment. Then there's the psychological toll of long-duration spaceflight. Astronauts on extended missions, confined to cramped quarters and isolated from loved ones, face the challenges of isolation, confinement, and the disruption of their circadian rhythms. Addressing these challenges is crucial for the future of human space exploration. Scientists and engineers are working on developing advanced shielding materials to protect astronauts from radiation, as well as self-healing materials that can repair minor damage to spacecraft hulls. Research is also ongoing on the psychological effects of spaceflight, with the goal of developing countermeasures to mitigate the negative impacts of isolation and confinement. Building the ships of tomorrow. Overcoming the challenges of space travel requires pushing the boundaries of technology. Scientists and engineers are constantly working to develop new propulsion systems, spacecraft designs, and life support systems that will enable us to venture further into the cosmos and stay there longer. One promising area of research is in the field of advanced propulsion. Chemical rockets, while powerful, are limited by their fuel efficiency. To reach distant destinations within reasonable timeframes, we need more efficient ways to propel our spacecraft. Ion drives, which use electricity to accelerate ions, offer a much higher fuel efficiency than chemical rockets, albeit at much lower thrust levels. Ion drives are ideal for long-duration missions, gradually accelerating a spacecraft to high speeds over time. NASA's Dawn spacecraft, for example, used an ion drive to travel to and orbit the dwarf planet Ceres in the asteroid belt. Another promising concept is nuclear fusion propulsion, which would harness the energy released from fusing atoms together. Fusion reactions release vastly more energy than chemical reactions, potentially enabling spacecraft to achieve speeds that are a significant fraction of the speed of light. While fusion propulsion is still in the early stages of development, it holds the potential to revolutionize space travel, making interstellar journeys a real possibility. New homes amongst the stars. As we venture further into the cosmos, the concept of space colonization becomes increasingly appealing. Establishing self-sustaining colonies on other planets or moons would not only provide a backup plan for humanity in case of a catastrophic event on Earth, but also open up new frontiers for scientific research, resource utilization, and human expansion. Mars, with its potential for terraforming and its abundance of resources, is often touted as the most likely candidate for the first human colony beyond Earth. The Moon, with its proximity to Earth and its potential for water ice deposits, is another promising target for colonization. Lunar bases could serve as hubs for scientific research, resource extraction, and even space tourism. Beyond Mars and the Moon, the asteroid belt holds immense potential for resource mining. Asteroids are rich in valuable minerals and water ice, which could be used to support future space colonies or even transported back to Earth. Companies like Planetary Resources and Deep Space Industries are already developing technologies for asteroid mining, with the goal of tapping into this vast reservoir of resources. Establishing a permanent human presence beyond Earth is a daunting task, but it is one that we are technologically capable of achieving. The challenges are many, but so are the potential rewards. By expanding our footprint into the cosmos, we can ensure the long-term survival of our species and unlock possibilities that we can only dream of today. To distant suns. While establishing a permanent human presence in our solar system is a monumental task, it pales in comparison to the ultimate goal of interstellar travel. The vast distances between stars pose a formidable challenge, requiring entirely new forms of propulsion and spacecraft design. Traditional chemical rockets are simply not up to the task. Even reaching the nearest star system, Alpha Centauri, which is 4.37 light-years away, would take tens of thousands of years with current technology. However, scientists and engineers are exploring a range of theoretical concepts that could make interstellar travel a reality. One such concept is the Alcubierre drive, which warps space-time around a spacecraft, effectively creating a warp bubble that allows it to travel faster than light. While the Alcubierre drive is still in the realm of theoretical physics, it demonstrates the willingness of scientists to think outside the box and explore seemingly impossible ideas. Another concept is the Generation Ship, a massive self-sustaining spacecraft that would carry a large population of humans on a multi-generational journey to a distant star system. While the ethical and logistical challenges of generation ships are immense, they represent a potential solution for spreading humanity to other star systems. Ultimately, achieving interstellar travel will require breakthroughs in our understanding of physics, and the development of technologies that are far beyond our current capabilities. A future written in the stars. Humanity's destiny lies among the stars. The cosmos beckons us to explore and push the boundaries of our knowledge. The journey will be challenging, but it unlocks profound scientific discoveries and technological advancements. The human spirit thrives on pushing boundaries. We've journeyed from the savannas to the skies. Now, we set our sights on the cosmos, driven by adventure and discovery. The future of humanity is linked to space exploration. The cosmos awaits and humanity is ready.